This is the Wingcap Nest. It features some high-res textures in high polygon environments, a lot of moving pieces with cool light effects to top it off. I posted a clip of this on Twitter before, and people seem to really like this, but they were in total disbelief that this is actually an N64 game, which is exactly why I will explain today how I've done all these things and made it run just fine on a real N64. Keep in mind that while the video I am showing here is recorded from an emulator, this runs on a stock N64 without any lag, and I will show some footage of that as well. All of this is part of my mod Return to Yoshi's Island, which is currently about 70% finished. The game reuses the wing cap, but it also adds 3 new cap power-ups for a total of 4 cap courses. It is intended to have over 160 stars. The cap courses all have Mario's struggle to make it through the level at first, but then, as soon as you unlock the new cap, you'll experience a complete sense of freedom. I hope that this way, the player can really appreciate the new powers. Also, a shout out to Bioback for helping out with the visuals, and a shout out to Badoop for making the music for this level. I'll link a video of the OST as well in the description if you wanna put this in your playlist. The light effects you're seeing are a mix of baked vertex colors and a fake point light. What do I mean by a fake point light? Well, let me explain. The N64 actually supports up to 8 directional lights. These directional lights act like an infinitely far away sun with different light color settings. We can rotate the direction, we can change the brightness, and we can even change the color of the light. By doing some simple math, we can compute the directional light dynamically, and we can have it act as though it was a point light. Computer graphics are honestly just about making the viewer believe something, and this one is very believable. Another huge thing making this thing look so high-res is the textures. The original grass on Mario 64 is a 32 by 32 texture with 2 bytes per pixel in the RGBA 16 format. We can do better by using a 64 by 64 texture with indexed colors. This has the downside that we can only use 15 colors, but it is grass. Grass doesn't need more than 15 colors. If we want the texture to have even more detail, we can use a multi-texture. Now, I say this is a 256 by 256 texture, but some special limitations apply. I'm not gonna explain the limitations in depth, but as you can see, this makes it look a lot grainier and a lot more detailed. Unfortunately, the limitations mean that we lose a lot of the color from the original texture, so we also have this option here, a 128 by 128 multi-texture. Now you can really see that this is a lot more detailed and it still retains the colors. Loading either of the multi-textures into texture memory takes 30 microseconds, so twice as much as the default grass. But honestly, the 15 extra microseconds is basically nothing in the grand scheme of things. We have 33 milliseconds per frame, so that's over 1,000 times more than what this takes to load. And considering how big of a part of the scene this grass is, I will take the 15 microsecond loss for this. Now if we want to, we can add some color back to the multi-texture by giving it vertex colors. And as you can see, this already has a lot more depth than it had before. In the end, I believe that it's personal preference whether you prefer the one on the left or the one on the right. The one on the right has slightly higher resolution, the one on the left has a few more colors. I went with the one on the right because I think it fits my level better. Another huge advantage of multi-textures the way we're using them is that you can make your texture bigger, which means that you will see the repeats less often while still not being blurry. If you look at the original grass on the left, you see that if we make it big enough to not be blurry, we see the same tile being repeated over and over, and it's very annoying to look at in my opinion. Compared to our multi-texture, you can virtually not see a single repeat. The background in this level is being rendered first, and it is being rendered relative to the camera. By having the background move together with the camera, it seems as though the background is infinitely far away, when in reality it is completely up close, as you can see. This gets us around the depth limit that the N64 would usually impose, and it makes this seem way bigger. And here you can see the game running on a real Nintendo 64. The original Mario 64 runs at most at 30 FPS, but in some really bad levels it even drops as low as 10 to 15. Currently, I have a limiter to not allow the game to go over 30 FPS. Putting it over 30 FPS, but below 60 FPS, is going to look very choppy, because some frames are going to be spaced 16.7 milliseconds apart, while others are going to be spaced 33.3 milliseconds apart. So don't be fearful, you can have it be limited to 30 FPS, but for the sake of displaying how much performance we have left over, I'm going to unlimit the FPS. And there you have it, the game runs almost 40 FPS here. This new engine is easily powerful enough for a level like this. Of course, all of this is only possible because of a major source code rewrite that I've described in this other video here. I will link this one too, and you should check it out if you haven't yet, it's very good. Since then, I found a few more optimizations that boost FPS by another 20-ish%, but that's for another video that I can make hopefully soon. This level here was 3D modeled and designed in a way exactly that it works well on the N64. And this is something that would only ever work if programmer and artist were closely together. Lucky for you, I am both a programmer and an artist. This enables me to, for example, make animations like the clouds down there. The math for them is super efficient and takes very little computation power, with the model being designed around the mathematical formulas that I use to animate the clouds. The N64 has a special texture format that halves the size of each pixel but limits your color palette to 256 colors. On a texture size of 32 by 64, that ends up being around 14 microseconds faster to load than a standard texture. To abuse this, the whole background of the stage was designed to only use 256 colors per part of the grid. Rendering the whole screen on an N64 once usually takes 5 milliseconds out of the 33.3 milliseconds that we have per frame. Luckily, for the background we can disable the Z buffer. This is something that games like Smash Bros and F-Zero did to run at 60 FPS. So as you can imagine, this speeds up rendering significantly. Since the background fills the whole screen, we actually don't need to clear the frame buffer anymore either. This saves a lot of rendering time. Our background uses 8 32 by 64 textures with 256 colors limited, that each takes 0x900 bytes. To compare, Mario 64 uses 64 0x800 byte textures. That's almost 8 times more, and I don't think it looks any better. Doing it this way also has the advantage of not having the background to move around in world space, so it feels like everything is fixated in the sky. But if you look at Mario 64's backgrounds, unfortunately, the clouds move slightly with the camera and it ruins the illusion. Since animated rigs in Mario 64 only rotate, they don't move or translate, we don't need all the functionality that a standard 4x4 matrix used in video game rendering would give us. We can cut down and turn our 4x4 matrices into 4x3 matrices. This speeds up every matrix operation up by about 25%, and it lets us move more animated characters around than the original game ever could. Overall, the matrix math is now about 5 to 8 times as fast as what is in a vanilla game. The matrix math is actually a huge limit on the original Mario 64, and it often caused the lag that you see in it. The original rigs have also all been reworked. Nintendo's software that they used to animate characters used to have a bug that would duplicate all the animation bones, causing all rendering to take twice as long on the CPU. This was truly awful, and it's the reason I'm remaking every original model that I intend to use. While I'm reworking them, I'm also giving them higher res textures and more efficient texture formats to make them prettier and cheaper to render. If you're interested in seeing me rant about the Bob-omb or other rigs, there's some fun videos on my second channel that I will also link. In my opinion, programming and maths are subjects that are best learned by yourself, and that is where today's sponsor Brilliant.org comes in. Brilliant has several courses on different math and programming subjects with interactive tasks laid out visually. They have many courses to teach yourself the basics of programming, but they also have courses for advanced stuff that teach you advanced concepts like neural networks with amazing visuals. This is honestly the most clear and concise way you could possibly visualize a neural network. And related to this video, look at this course on optimization. It has some cool graphs to go along explaining why some algorithms are faster than others. Anyone can get started and become a programmer by themselves. If you want to try it, head over to brilliant.org/caseemmanuel, and the first 200 viewers will get 20% off a membership.